Lesson 33b, simplifying radical expressions. In the previous two lessons, we defined rational numbers, irrational numbers, and then we started doing some things with irrational numbers. Specifically, we took square roots that weren't perfect squares, which made them irrational, and we estimated to the nearest integer. We figured out between what two integers it might lie between, and then we started estimating to the nearest tenth and to the nearest hundredth and to the nearest thousandth by one specific method. But sometimes we don't want to do that. Sometimes we want to simplify a radical as far as we can algebraically. And that's what today is all about. And in order to do that, we need to utilize a property of square roots dealing with multiplication. So the multiplication property of square roots says that if a is greater than or equal to 0 and b is greater than or equal to 0, we can either split up a radical or we can multiply radicals together. This goes both directions, and we will utilize both directions in the lesson today. So what in the world am I talking about? Well, if I have the square root of 20, what I want to do when I'm doing this process, and you really should write down this example somewhere off to the side of this rectangle in your notes. If we have the square root of 20, what I want to do is I want to break it up into two square roots that multiply together to make 20. But not just that, I want one of them to be a perfect square. And not only that, I want it to be the biggest perfect square that would go into 20. So what I am saying is this. I want to break this up into the largest perfect square that goes into 20, and then whatever the other factor is that will make 20 when we're multiplying. Okay? That's how we want to start simplifying radicals. So if I'm going to do that, what is the largest perfect square that will go into 20? Just say it. 4. So in other words, what I'm saying is we're going to break 20 up into 4 times 5. And all I've done here, right here, is I have utilized this property right here. I've split it up into two numbers that multiply together to make the number underneath the original radical. But from there, then, I want to simplify this. The reason why I did this is because I can simplify this square root right here. By the way, what is the square root of 4?
2.
It's 2. So what that means is that this simplifies into 2 times the square root of 5. Or sometimes we phrase that as 2 square roots of 5. All right, I'm going to take this off and because I have it all done here. Step by step. Same thing. And that becomes 2 square roots of 5. And we read that as 2 square roots of 5. So this is actually a very simple process as long as you know your multiplication facts and as long as you're consistently looking for, once again, that largest square root that will go into the number that you're trying to find. And that's the key. Because sometimes there's more than one square root, perfect square root, that will go into a number. Okay? All right. So, square root of 18. I want to break this up into two numbers that multiply together to make 18. One of them I want to be the largest perfect square that will go into 18. What's the largest perfect square that will go into 18?
9.
It's 9. So we're going to break 18 up into 9 times 2. Which means that breaks up into square root of 9 times square root of 2. And we can simplify the square root of 9. That's why we did this. It is 3. So that means the square root of 18 simplifies to 3 square roots of 2. So sometimes we want to estimate irrational square roots to the nearest integer. Sometimes we want to find out between which two integers it's in between. Sometimes we want to estimate to the nearest tenth or the hundredth or the thousandth. And then other times we want to simplify algebraically the radical. Okay? All right. Now, I'm going to show you something else here. What if you thought, well, I'm going to break that up into square root of 6 times square root of 3. Well, that doesn't help you because you can't simplify square root of 6 or square root of 3. They're both irrational. So that doesn't really help you. You want to find, once again, the largest perfect square that will go into the number. And so what that means, and I thought I had one other thing there. Let me back up for a second. Oh, okay, I was just reiterating what I just said. Okay. All right, how about this one? Quickly turn to your shoulder partner and talk about how you think you might simplify that radical. Sometimes simplifying the radical really can't be done. If I list out all the factors of 35, the only one that's a perfect square is the square root of 1, but that doesn't help us simplify anything. So what that means is that it's already simplified. So how do we write the answer? We write the answer as square root of 35. All right, so let's do a little bit of practice now. And before we do that, this was what I thought was on the previous screen. These perfect squares are things that we need to be aware of. And it's up to you whether you want to write these down or not. You know, those are all based on your third grade multiplication facts. Many of you probably know them all the way up to 300. But these are all the perfect squares up to 300, where the ones that are above your multiplication facts, the square root of 169 is 13, square root of 196 is 14. Or in other words, 14 squared is 196, 15 squared is 225, 16 squared is 256, and 17 squared is 289. You're going to run into a lot of these numbers a lot when you're dealing with the simplification of square roots. All right, I would like everybody to try number 1 and number 2 in your notes. You're trying to break each of these up into numbers that will multiply together. In other words, they're factors of the number such that one of them is the largest perfect square that will go into it evenly. So 32, we can break that up into the square root of 16 times the square root of 2. 16 times 2 is 32, and 16 is the largest perfect square that goes into 32 evenly, and that simplifies to 4 square roots of 2. Number 2, same idea. The largest perfect square that will go into 200 is 100. So we break that up into square root of 100 times the square root of 2, and that simplifies to 10 square roots of 2. Any questions with regards to number 1 or number 2? Yes?
Hayden and I got 2 square roots of 8.
2 square roots of 8. Well, this is basically a lead-in to something I'm about to get to in about 5 minutes. But 2 square roots of 8 for number 1. So I guess this gives me the opportunity to talk about it right now. So here's what you did. You said square root of 32 is equal to square root of 4 times square root of 8. That's what you said, right?
Yes.
All right. That's 2. So you got 2 square roots of 8. But look, even if you don't see the largest perfect square the first time, you need to at least look at what you have left. For example, what I got there is not a perfect square larger than 1 that will go into 2. So that means I'm finished. Same thing here. But you can't say the same thing about this. Do you understand what I'm saying?
Yeah.
Okay, what am I saying?
You're saying that you cannot put a perfect square larger than 1 into an 8.
Really? This is a question for all of you. Is there a perfect square larger than 1 that goes into 8? Yes or no?
Yes. Yeah.
What is it?
4.
That means it's not simplified all the way. No, so how could you take that, and this is the only reason I'm bringing it up, how could you take what you have there and still get to the answer? Well, this is what's coming up after this slide, but I'll go ahead and I will show you now. So we have 2, and then this right here, square root of 8, is square root of 4 times square root of 2, and that's 2 square roots of 2. So I'm going to take that, and I'm going to move that down here. Change pens here. So now I have this. Are you okay so far?
Yes.
All right, and then we have these 2 non-radicals on the outside, and look at what I end up with. Now, it obviously took us a lot longer to get there, but you can still get to the total simplification as long as you double-check what you thought it was. Okay? All right, everybody quickly do number 3 and number 4, please. Square root of 80, the largest perfect square that goes into 80 is 16. So we're going to break that up into 16 times 5. If you tried to break it up into square root of 4 times square root of 20, as I just explained for number 1, you could still get there. It just takes a little longer to. But finding the largest perfect square that goes into a number evenly, that's the easiest and fastest way to get to the simplification. So we get 4 square roots of 5. As some of you found out in number 4, other than 1, there's not a perfect square that will go into 30, so therefore it is already simplified. So that means the answer for number 4 is just square root of 30. All right. So we already kind of got a lead into why number 5 is in the lesson today. So I'm going to go ahead and have you try number 5. Let's go ahead and deal with this. And once again, there's a reason why this problem is here. Some of you broke up 72 into 36 times 2. That's what you should do. 36 is the biggest or largest perfect square that goes into 72. And quickly, you get to 6 square roots of 2. There were a few of you who broke up 72 into 9 times 8 because you thought, hey, 9's a perfect square. It goes into 72. And so you simplified that, and then you got 3 square roots of 8. Well, much like the one that Spencer asked about earlier, we still have a perfect square that goes in to this right here. What perfect square goes into that? 4. That means you're not finished. And you can still get to the answer. I'm certainly not saying take what you've done and erase all of it and start all over again. Just continue on. So now, break up 8 into the square root of 4 times square root of 2, like this. And we end up with 3 times the square root of 4 times the square root of 2, and square root of 4 is 2. And so we can still get to 6 square roots of 2. It just took a little bit longer. So make sure when you simplify that you check your answer. And make sure the number that is underneath the radical in what you think is your answer, make sure that there are no longer any perfect squares that will go into it. Okay? All right. Easiest to find the largest perfect square that is evenly divisible. All right, so now, what if you start off with a number on the outside of the radical? Make sure you take good notes on this problem. This means 8 times the square root of 120. That's what that means. So if I, from here, do what I did in 1 through 5 and simplify the square root of 120, I will then take that answer and multiply it by 8. I'm going to do all the work for you. The biggest perfect square that goes into 120 is 4. So I'm going to break that up into square root of 4 times square root of 30. And notice I made my 8 a different color so you can see exactly what I'm doing. The square root of 4 is 2. So now I have 8 times 2 times the square root of 30. The standard rule is this. You can multiply a non-radical with a non-radical. The 8 and the 2 are non-radicals. And you can multiply a radical with a radical. But you can't multiply through a non-radical with a radical. And hopefully that kind of makes sense. So from there, that gives us 16 square roots of 30. Okay? Questions on how I got 16 square roots of 30? What you have to be careful with here, and this is what I was just saying, you can multiply non-radical with non-radical. That's how I got that 16. But I don't want you to ever think that, like, for example, these two make square root of 32. Because they don't. You can't multiply a non-radical through with a radical. That's what I was just saying. Okay. So this is just an extension on what we just talked about. All right, I would like everybody to please do number 5, 6, 7, and 8. 6, 7, and 8. That whatever you get, it's going to be 5 times whatever the square root of 54 is, which we just did a bunch of problems where we were dealing with that. So it's we're going to break up 54 into square root of 9 times square root of 6. Square root of 9 is 3, so we now have 5 times 3 times the square root of 6. We can multiply the two non-radical numbers together, So that simplifies to 15 square roots of 6. Number 7, which is right below that. It is negative 7 times the square root of 48. So we need to simplify the square root of 48. The largest perfect square that goes into 48 is 16. So we're going to break that up into negative 7 times the square root of 16 times the square root of 3. Square root of 16 is 4. So we have negative 7 times 4 times the square root of 3. We can multiply the two non-radical numbers together of negative 7 and 4. That makes negative 28 square roots of 3. Number 8, other than 1, there is not a perfect square that goes into 42 evenly. Therefore, it's already simplified. So number 8 is 5 square roots of 42. All right, back side of your notes. Everybody try 9, 10, and 11. This is kind of a summary of things we've been doing today with a little bit of what we did last week. Negative 3 times the square root of 40. We need to simplify the square root of 40 if we can, and we can. 4 is a perfect square that goes into it evenly, so we're going to break that now up into negative 3 times the square root of 4 times the square root of 10. The square root of 4 is 2, so now we have negative 3 times 2 times the square root of 10. We can multiply both of our non-radical numbers together, the negative 3 and the 2. That simplifies to negative 6 square roots of 10. Number 10. The largest perfect square that goes into 180 is 36. So we break that up into square root of 36 times square root of 5. That is 6 square roots of 5. We've taken a look at number 11 in two different ways. What's one possible answer to this? Any idea? I don't want the imaginary number version yet. What's the answer to number 11? No solution or no real root, however you want to phrase that. If you do it as imaginary numbers, because I have briefly talked about that, what would that be? No.
Is it 12i?
Is it 12i? Well, let's see if it's 12i. This means 4 times the square root of 9. I'm going to break up square root of negative 9. I'm going to break that up into this. Oops, 9. This, by definition, is I. This is 3, and that is 12i as an imaginary number. Okay? All right, last thing for today. What if we have a square root times a square root? Well, now we just go backwards. What you should do is multiply those two numbers together because, like I mentioned earlier, you can multiply a non-radical with a non-radical, and you can multiply a radical with a radical. This is a radical and a radical. We can multiply those two together, and then it's just what we've been doing all lesson long. Simplify it as far as you can. So we're going to end today with 12 through 15. Let's do all 4 of those, and then we'll compare with our shoulder partner. Number 12 turns into 5 square roots of 14 after we multiply the two radicals together, but we can't simplify square root of 14, so therefore we are finished. Number 13, first of all, turns into 7 square roots of 12. Can I simplify square root of 12? Yes or no? Yes. Not a trick question. Let's try that again. Can I simplify square root of 12?
Yes.
Yes. It's 2 square roots of 3. And here's the reason why. And then 7 times 2, the two non-radicals we can multiply together, so that simplifies to 14 square roots of 3. Number 14, we multiply the two non-radicals and then the two radicals, but I cannot simplify the square root of 15, so therefore I am finished. Number 15, same idea. Multiply the two non-radicals and then the two radicals. Question to you, can I simplify the square root of 50, yes or no? What perfect square goes into 50?
25.
25. So that breaks up into this. Square root of 25 is 5, and now I can multiply the two non-radicals, so that simplifies to 30 square roots of 2. Any questions? We will get a lot of practice at doing this over the next 3 lessons, so if you're not good at it right now, you will be in a few days. All right, we are finished.